Okay, so welcome to the MATC seminar. It's my pleasure to introduce Mr. Dwight Clark, who's been a friend of our center for many years. He's a bachelor, he has his bachelor's from Oklahoma State University and his master's in business administration from University of Phoenix. He's had over 37 years of experience in the railway industry, which a lot of it will come out in this presentation. And he retired in October 2017 and immediately, like a lot of folks from UP, didn't really retire, became president of AREMA, and I wrote it out so I wouldn't get it wrong, the American Railway Engineering and Maintenance of Way Association, and he currently serves on the executive board as past president. And today he'll be talking about emerging technologies in the railway industry. And Dwight, I'll let you take it from there. Thank you.
Thank you, Larry. I appreciate the honor to be here. You know, you guys have a great program here, and I really appreciate all the things you do as far as the research area, what your guys are doing. Undergraduate, you know, I mean, it's pretty cool when you look at all the labs and stuff you guys are doing. Great work here, so I really appreciate the things you're doing here. Okay. All right, I'm going to go through and I'm going to talk about, you know, the title of this is talk about the railroad perspective, emerging technologies, and things I'm going to talk about. First of all, I'm going to talk about AREMA and talk about the U.S. rail research, talk about TTCI overview, technology review. I'm going to talk about some of the recent breakthroughs, talk about some of the emerging technologies. Also, we'll talk about the developing technologies. Okay, first of all, background on AREMA. So anybody familiar with what AREMA is here? Few, okay. Basically, this is an association. It's about 6,000 people strong, and it really gets into the railroad engineering side of the business. We set standards. There's a whole bunch of different things we do. So I'll kind of build a little bit about that. But we have AREMA's been a really good association for me to be involved with. Is our 38 years life member, like ASCE, a life member of ASCE also. So I recommend becoming a member if you're going to be in a railroad environment. It'd be a good thing to be involved with. So you kind of see what goes on, learn the technology, kind of meet the people. So the education and primary mission of AREMA, we have very good educational opportunities at our that are out there. We have a lot of in-person seminars. We do a lot of web-based educational programs. And we put out a lot of best-selling railroad publications. So there's a lot of publications out there that help you, that a lot of people reference them when they're doing standards or whatever, they kind of get in that area. So we have a conference that we hold, annual conferences, and we also have student chapters. So we got a lot of new growth in student chapters. So when I started working with AREMA, we did not have anything as far as student chapters. We have 23 student chapters now. So across the country, these guys are, you know, integral part of our association. And, you know, we've seen really great growth in this over the past decade. So basically the student activities, we have things out there to support them, what we call the next generation. You know, we were sitting back at UP, we were sitting back looking at who's going to be our next people to take our positions when we leave and stuff, because a lot of people, I was at UP for, 38 years. So you're kind of like, well, who's going to come in and be able to take your position when you leave? And so we had to start developing those people. So we started hiring, hiring a lot of people. We've had a lot of people come in from the UNL here. I think we've had some UNO guys. So we've had a lot, there's a lot of young guys that come in that we've, see that we need a big support for them. And so I think it's a good thing for us to get, try and get all the members and stuff. So this was something that AREMA has been working on, trying to get people, and that's how we've tried to build this student activities. And so we also have a lot of scholarships out there. We gave 39 scholarships last year. and $79,000. So some of the things, we're trying to push things on key technology. We also get into a lot of things as far as web briefings and courses, to seminars. We've got technical committees, and that's kind of the key part that drives all the regulations and stuff. And this is made up of all volunteers on these different committees and stuff that kind of set all the standards and that. But, you know, so that's something, if you're involved, you know, interested in that, that'd be something you get involved with and to start getting involved with AREMA. We really trying to push a lot of things on with the diversity. Also, we have a AREMA Board of Governors that continue to improve our strategic plans. So I get a little bit about AREMA. Now let's start talking about railroad research data. So the highway research estimated about $800 million, is that about right? And the railroad research, we're only about $48 million. And what kind of drives all this, the AER, we have 7 class 1 railroads that basically fund and steer the research. So TTCI is where we kind of do that through, and we kind of go through and decide what we want to do as far as projects are concerned out there. And there was actually 4 affiliated universities that they were providing money to. That's kind of stopped now, where they're going out and trying to find on individual projects. So that's something that's brand new that they've been working on. So if you have something that's that's a good bestseller, you know, it would be looked at by a committee with the AER group, and they would make a decision on what the projects are. So that's something that's out there now that's a little different than what we've done in the past. And a lot of our class 1 railroads fund our own internal projects, but there's not very much money in that. You know, that's something that's been a really hard thing for us to do. You know, we really try every year, we try and lose operating our rate, or I guess our maintenance cost now, I guess, and that would kind of go in the maintenance area. Unless you could do a capital improvement area, then you can, you know, fund things through the capital area. But that is something that the roads just don't have a lot of money to do that internally nowadays. A lot of the suppliers develop their own initiative products. And also AR has been in some funding and stuff. I think you guys have been funded here in different projects, different years. So what's TTCI? So basically, this is a group that's owned by the AR. It's located in the middle of Pueblo, Colorado. Larry's been out there. Yeah, it's been out there. Kind of in the middle of nowhere. You drive from 22 miles from the Pueblo Airport in the middle of the desert, and then you get TTCI. So there's some pretty cool stuff and a lot of good research there. I really like to do a lot of research there if we can do that. I like to do it internal on our railroads also, but this is a good place to go out there. If we can break it out there, then it's not going to break on a railroad when we go out and test it. So that's something that I've always tried to do. I've tried to always try and push the vendors that they will go to TCI, get approved there, then we would go through our process of approving it at UP. We test new components and vehicle materials, and also the train net that's 17,000 tons, 110 car train that runs a bi-directional on the HDL loop out there. So HDL stands for heavy axle load. So we also have what we call HDL Mega Sites testing that's done, and there's 3 sites. So one is here, actually starts in Nebraska. It's kind of north of Kearney, goes up into the coal basin. And so that's the heaviest axle load in the world. It comes down through that, or it comes down to Nebraska. And, you know, that was heavier when we were doing all the coal stuff coming out of there. There's also one on the eastern, which is on the our eastern mega site, also on the northern mega site. All have different types of characteristics. So this is kind of some of the latest track design characteristics. We try and make sure we have a good solid foundation out there. We make sure we've got good drainage. We try and have, you know, make sure we use concrete ties, we use continuous water rail. Also the things we really try and push is velocity. That's something that's a key part of the railroads is making sure that we can keep trains running faster across the railroad. So anything that doesn't, interrupt our operation comes in our design processes. So these are some of the things that we do here to help that. So here's some of the track components. Concrete ties with the elastic fasteners. You guys probably can see concrete ties around here. If you look, you'll see concrete ties around the track. I think BNSF has some around on some of their tracks there. We have a lot of the ties. And the ties are really good. The only problem we've had with them is when we have bad concrete mix. And we've ended up having some big problems with that. And, we've really had to push that area. So that's one of the issues that we've had issue with. We also have, we use a premium rail steel. We use a 141-pound RE, which is a standard. And we use a 415 Brunel. Now, the interesting thing about these rails here, they're 480 foot long. So, what happened is we used to have 80-foot rails, and we get these from Japan. What they do is that they would cut the rail, and they would make it 480 foot. They would cut it to 80s, ship it, and then we'd weld it back up to the 480. Then we'd put it on our trains. So now we've got a ship that we can load this up on the ship. So that saved us 17 welds out there. Weld is a weak spot in the railroad. So we were able to save that 17 welds, which is huge for us. We also have we use insulated joints. And when we started out working with joints, the joint is where you have a circuit in the rail that you communicate. So like if a signal, if a wheel goes over that, then the signal system knows the wheel's in there. So these don't last very long. So we were able to get these Kevlar insulated joints, and we got like a million, probably a mile or gross tons on them, I would say, on it. See, also we've done things as far as trying to get rid of the joints in the trails. We don't like joints. Also, we use a flange or bearing frogs, and we use high-speed turnouts. So another technology we've done is track geometry, and these are highly sophisticated cars. That car there, you see that's actually on the top is a $8.2 million car with all kinds of technology on it that goes through, and we run down the railroad and we collect information about the rail. And one thing that's important for us is understanding the health of the rail. So this gives us the health of the railroad. So every day we have information that goes into our systems, and we see where we got problems at that prior to systems. Well, we have a very sophisticated computer system at UP that we were able to go in and see where the problems are at. And then the maintenance guys would get information that they know what they could do, where it's at, where the problems are, every day, and they would work through that. So they have a to-do list or a maintenance planner, we call it, where they would go through and have that information go out and do work on it. But it's pretty cool stuff out, very highly sophisticated stuff that we're doing. So here's some of the newer things that we're doing, like with the remote track assessment. So we have a thing called BTI. Now this was technology that we started in 2000, I guess it's about 2006. And so this is technology that runs on G-forces on locomotives. And we have 53 locomotives that go across the road that gives you 24/7 information on the track, but it's hitting like, it's hitting like impact type of information. And this has been pretty cool because with running this, 24/7, if we have a high hit, we are able to send our maintenance guys out to that spot. He'll get a high hit on his phone, and they need to go out to that spot and tell us, so they get a GPS location, everything, where that spot's at, and they get out and take a look and see if it's a problem or not. If it's not a problem, then they would, maybe they would at least investigate it, or it would go and maybe if it's a medium hit, then it would go into like our maintenance bucket, and then they have 7 days to do something with it. Yeah, another thing on here is the M-rail track deflection that was developed here. I don't know if you guys know that. That was actually developed here at Lincoln. That was Shane Farrader. They had done that. And so that's a really cool thing. One thing we learned about, and we were able to build off of this, is there were spots on the railroad where we had the concrete ties, and there'd be about 10 ties in a row. They started zipping, and we wouldn't be able to see it on our track stuff because we didn't have a profile that was that short. So we come up with a 10-foot profile that we build into our geometry cars that we're able to find this stuff. But I mean, that was stuff that we didn't know what was going on until we were able to, you know, they built a system here. Okay, the other thing is they're doing a lot of things with the autonomous geometry, which is, you know, locomotives. There are some people putting in cars. I'm still a fan of locomotives because you put the weight with those. And so this way, you know, if you're running these on locomotives, then you're getting a 24/7 look. So we run 24/7 days, you're getting your healthy railroad. The other, yeah. So, okay. The other thing here is machine vision. You guys have done a lot of machine vision stuff around here? Not. So why machine vision is very important for us is that, you know, that we can get a concrete tie evaluation. So it'll actually go out and look at ties and count ties. So you can do wood tie evaluations with this. You can do rail surface conditions with this. You can do joint bar inspections. You can do your rail branding inspections with it. Also, you can do fastening recognition and evaluations. Also, you can do like rail seat abrasion on concrete ties. So this is a huge thing for us. And then when I talk about understanding the health of railroad, this is one of the things that helps us understand the health of railroad. So here's another thing we got. This is kind of the next level of the machine vision. We've got a system. This is actually near North Platte, Nebraska. So this is called full train inspection. So we run trains, you know, at speed down on here, and we can do, you know, tell them, well, okay, you guys got bad wheels. Maybe you got a problem with the bars. So when they get over to their, they get to North Platte, they know what the problem is. So the maintenance people that maintain the car fleet over there know where to go to. So another thing is ultrasonic rail fly inspection. And this is, we do broken rails are probably our top cause of derailments on the railroads. So, you know, basically we've made huge progress in trying to, you know, understand how to see these out there. And, but the challenges are on surface conditions. You can't see down through the, you know, put your ultrasonic beam down through the rail. And, you know, if you have surface conditions on there, you got to keep, you know, you have grinders out there to try and keep that off, or you have to have cars that can see underneath that. So that's something we've worked on, you know, very diligently trying to understand that. And so the other thing that's kind of more on the developing technologies things, they're doing some things as far as laser-based and ultrasonics. Also, we've done some phase arrays. Now, what phase arrays are is like, instead of having like the ultrasonics where we're putting a beam down through this that's looking for, you know, like a defect in the rail, what the phase array is at multiple angles. So, you know, so you're seeing underneath areas where you can't, you know, where you might have a problem with the rail conditions. Okay, another thing we do, we have track renewal trains out there. You guys, if you guys ever been up along the DP line, you might see these big old long piece of equipment up there. But we can do 2 miles a day with new track and stuff. And so they'll take out the old ties, rail, and they put in concrete ties and rail with this. So we do like a 12-hour window when we do this. And you know, we're able to put in a new rail and all this stuff. And also we're in your critical corridors. We can, you know, we have a lot of good features that we can do with this piece of equipment that helps us, you know, turn over or less time, I guess, out there to do it during the normal gangs. The normal gang would take you a long time to do that work. So some of the technology off the evaluation car is, look at that bottom picture there. So we can send pictures or information to that tamper surface of track out there. We can send information from that geometry car over there so they can go out there and find the spots where they need the surface. So all that stuff is electronic. You know, we do GPS do that. And another thing that's kind of cool with the GPS thing is you look at the bottom picture of this, a fully automated ballast distribution. So when I was working as a roadmaster out there, we used to be under those cars with ties dragging, dumping the ballast. So you have chains and you're hanging on there to dump the ballast and control it with this. So this is all automated now. Based on the GPS, the information from the evaluation car tells us where the problems are. So if we have work there resurfacing or whatever, this is all automated. So if you'll see trains running around the railroad where they got the doors opening and stuff, they're doing this automatic now. So in closing, U.S. Rail research lags the last railroad in the developed world. North America has a world-class facility to pursue additional research opportunities at TTI and Pueblo. The FRA does disperse limited research funds for universities and UTCs. Recent technology breakthroughs are paying off through improved safety and productivity. Exciting time for industry involved with the railroad industry. Consider AREMA. Thank you.
So when you're talking about the difference between the lumber ties and the concrete ties, I'm assuming that the concrete ties pay off in like structural like integrity, better performance. I'm guessing they might be more costly. What are the general payoffs like between the two?
The payoff is life. You know, if we get the life that we're projecting is a 45-year life, if we can do that 45-year life on there, that tie is going to be a better tie. You know, your wood ties, your average life is about 20 years, and it also depends on where you're at, because if you have a wood ties like down south, your life might be only 7 or 8 years. You know, where you got a lot of high humidity, things like that. You know, you get a lot of termites and stuff. You get the same wood ties up in Idaho, for example. You know, that life out there might be 45 years for that same wood tie, but it really depends on where you're at. So, good question.
My question more relates to the safety side of the system. And in particular, what are your new technologies, I guess, that you're exploring or already implementing that really involve connecting the train to unknown vehicles that are going to be passing by and really become involved with the crossing then on these networks, such that both the automobile could be alerted or the train could be alerted of an impending incident? Where do you stand right now with those types of technologies? Are you working on them? Is AREMA coming up with standards maybe that others should follow? And are the actual railroad industry implementing such systems?
They're really not right now. I mean, it's when we sit down and try and figure out what we're going to do for research, we kind of, it's just like you guys are. You have to figure out where the best bang is for the dollars, and so they try and prioritize that. I mean, we start out with a list of projects, and we get down to about TTCI. We get down about $12.8 million of budget for research. So it kind of limits that a little bit, but it's not, there's people that want to fund something like that, then that's something that people are willing to look at, I think.
But just as a follow-up, the railway industry in the U.S. has been doing this positive train control. Would you mind, again, that sort of follows Ron's question. Would you mind discussing that and where the industry is in implementing that?
So, I mean, a lot of the railroads are, pretty much all have that all implemented. For example, Union Pacific, it cost us $2.1 billion of unfunded money that we had to come up internally. So if you come up with that money, where does it come from? You either got to sell more freight out there, or it's going to come from somewhere else, and it comes from someplace else. And so, like, it was a technology that that's been a problem. But we worked on this for years and years and years, trying to get the technology to work out there, because we wanted to do that, but we couldn't get systems to work, and they still had that problem. The systems don't work really well. So even though they put the mandate out that you got to do this, that's kind of what that's been one of our problems that we've had to fight through that. But we've done. I mean, they've got things implemented. They spent a lot of money on it, and but the systems that we were trying to implement weren't even developed yet. Yeah, good question. Thanks.
So thank you very much for the presentation. So I got an observation, then a question. The observations for the students, we often think of, and wrongly, society thinks of the railway as an old technology, an old system. And I think from this presentation, you saw that they're actually much more innovative than in a lot of the transportation systems out there, and particularly the highway, in terms of monitoring and maintenance and operations. So that's what I wanted to thank you for that, Dwight, for bringing that out. What do you think of the opportunities are for our students in the audience in terms of railway careers, just in general, and then specifically working with some of the technologies you talked about?
Well, I think that I guess railroad career-wise, I think that it's a great time. This is a fun time to be in the railroad environment. I mean, when they had this retirement thing come up, I really wasn't planning on retiring, but it was one of those things I couldn't refuse. And it's kind of one of the lifetime things when they offered this thing. I put in for it. Now I was the only guy who was really doing what I was doing at UP, and I put in for this thing. I didn't think nobody would give this to me. They gave it to me, and it was like so I wasn't 62 yet. I was 61 and a half, and the thing made me like I was acting like 65 years old, and they gave me a whole bunch of other things on here. So it's like, if I don't do this, I won't get this till I'm 65. So it's kind of like it was no brainer, But because part of the problem was I was just going in as president as the AREMA, and you have to be working for the railroad to be president, or starting your term or whatever. And this all came out. They let me know the day before we were leaving to go to the conference. So I had to I had airline stuff, so I had to change that, get it all put on me and all that stuff, so there were a whole bunch of stuff. The real stuff now they don't pay you. It's it's a volunteer thing. And so I had to get all that turned over, but the AREMA people were gracious because I was kind of the first president, and they funded my travel and everything for me on this. So they made it so I was able to do it, basically. But like I said, I think as far as opportunities I think it's great. I think there's a lot of neat things out there. Technologies, there's so much new technology out there. Every day there's something coming up that really, we get better technologies, better computer system, algorithm stuff, the big data stuff, or electronic stuff. And just for your information, I don't know, you guys probably don't know this, but UP probably is a state-of-the-art computer system for our engineering systems. And, people come from all over the world to kind of see what we do and stuff like that. So I was very blessed to be able to have systems like that we could use to make decisions on the railroad. So we're making sure we're getting things in the right place in that. But that's kind of the challenge of going in, the railroad, career-wise. I started right out. I actually worked for the railroads when I was going to college, and then after I graduated, I went full-time work for the railroad. So I was a second-generation railroad. My son's a third-generation railroad, so he works for UP now still. So you get the negatives are you can move a lot. But I think we're moving less than what we used to do. I mean, there was times when we were in my career, we were like every 8 to 10 months, you were moving somewhere. But we always said it's being a challenge. So, had a great wife and family that supported me and stuff like that. So that made it easier for me. Okay.
Thanks for presentation. I have a couple of questions about the research situation over there. So you said $48 million research.
Mm-hmm.
Does it include from government and commercial
That's everything.
That's everything. So I wonder distribution between the two groups. And the next question is, so what is the main reason that the small money research compared to other countries in the United States?
Yeah, well, it's because I guess the difference is the big difference is the foreign railroads are all funded by the government. So they run the railroads, they fund all the research and stuff. The railroad, we have to pay our own bills, so we don't get money for doing research at our railroads. So we got, I mean, that's part of the issues that we have to do. We have to go up and fight for, when we do research, we have to say, okay, what's the return on investment to do that? So that's the things we have to sell internally to our companies and stuff. And even like when we do all this stuff with TTCI, we have pages and pages of proposals that we go through, and we all have ROIs and all that. What's the return on investment? What's the safety? All that, so that's stuff we look at from the higher levels on, when we decide on projects.
And the government versus commercial, what is the percentage between the two groups regarding research funding?
I don't have it right now off my head, but
No.
the 48 is the total of everybody in on there. So, yeah. Well, I can tell you TCCI funding was, that was about 10 or 12.3 million funding.
I'm interested in the how or what reason that caused the train derailment, and what
The number one cause is the broken rails derailments.
and what the emerging technology working on that issue.
Well, let's see. I think we get into broken rails is probably a big thing. We get into a lot of mechanical issues. One of the things that I think we've got some issues going on, and I've been, something we've got to work more on. We're doing bigger and bigger trains out there. And I think that that's a problem because we don't understand all the dynamics out there on the railroad, because you're running, you got these big long trains, and if you'll see trains in the middle, you'll see trains on the front, on the back. Sometimes you'll see them in the middle. But when they go around the mountain territories, it's going up and down hills or going around curves. The force on the train can cause things to happen in the train that we don't understand all the forces on that. And that's something that is something that we've, we need to continue to look at. I'm a big proponent on that.
I have another question. It's beyond this topic. So, do you think, based on your almost 40 years working experience, do you think that the United States is planning, or their development goal is, how about the high speed train? Because like China, because they are developing.
So why don't we do high-speed trains? And I mean, we have, UP has one. So we have a line that goes from St. Louis to Chicago. But we, as a company, would not build high-speed tracks because there's not a return on there. There's really no return on running passenger trains out there. Like in Europe, all that. That's all funded by the government, so that's a little different. But we're funded by ourselves. So if we don't make money there, then that's a problem, for us. Yeah.
So Dwight, the other group that's in here are faculty interested in interested in research.
Yep.
So I'm going to put you on the spot.
Mhm.
You could name like the top 3 things you think would be, a need for the industry, and just to give it some insight to the researchers in here. And I apologize for putting you on the spot, but I'd be interested, based on your experience and all your experience in research in AREMA, if you could sort of say the 3 holy, sort of the holy grail of research.
I think, while you hear me talk about understanding I guess what's out there. So that's a big issue for us. And what we have out there on a daily basis is something we under. So things that help us do that better is good. A lot of technology out there doesn't work. So we'll get technology, and so people say, here's the technology, and it supposedly works, but we go out there and test stuff that we don't find that it works somewhere. That's why we try and push some of the technology other places. But I really want to understand the health of the railroad. I need to know when I send somebody out, if I send a maintenance guy out there on his phone to go out there and see what's out there, I need to know it's there. And we get him up in the morning at 2 o'clock in the morning, you know, because he gets a phone call. His stuff has got to be there. And so those are important things. Understanding rail stuff's important things. You know, trying to be able to get underneath the surface issues that's still an important thing for us. Understanding there's a lot of things that go on with the trains also too, like the train inspection stuff. Make sure we understand all that stuff. You know, I think all the machine vision stuff is big. I think that if you do machine vision stuff for, you know, trains, ties, all that, that just helps with our whole health of our system or whatever. See what would be some other areas. I mean, just trying to think about. We've got you know, we kind of prioritize stuff. CWR is still an important thing. Understanding. We've developed continuous weather rail is a problem for us. You guys did some work here. Professor Turner did some work on that. I don't know if you guys know that, but he has some funding from FRA on that. So they did some good work on that, but that's something, understanding what the force in the rail is. So we lay rail on the ground, we need to make sure we maintain it at the right level. So what we call that is neutral temperature. So when we lay rail, we have, like, for example, Nebraska, we're going to probably lay the rail probably about 100 degrees. You know, might be 90 degrees in some areas that you lay rail at. Some places you're laying at 125 degrees. But what that has to do is that the rail, when the rail adjusts just from heat and stuff out there, you're able to maintain a track. So, but that was, like I said, that was something, you know, I know you guys were doing some work on. One thing that I think would be huge for us and is I don't think we should have, you know, I'd like to get rid of insulated joints. You have these insulated joints out there in the rail. So that's where, you know, you connect the two rails together. And so if whenever a wheel goes over onto that other circuit, it shunts the track out. So they know a train's there, or it could be, you know, somebody could be following the track. You know, I'd like to get rid of that stuff. You know, if you get rid of that with some technologies and stuff, that's huge for the industry.
Any more questions? Well, Dwight, I'd like to thank you again for giving us an excellent presentation.
All right.
Small.
All right. Thank you very much. Thanks.